Okay, so now we're going to talk about Hooke's law. Hooke's law. This law is a very important law in engineering. Of course, you know from your tertiary and from your secondary school, you will know more about Hooke's law. But here we're going to give you more insight about what Hooke's law states. Okay, now Hooke's law is for materials that obeys elasticity. Any material that obeys Hooke's law is known to be a Hookean material. Now, what does Hooke's law state? Hooke's law states that provided the elastic limit of the material is not exceeded, provided the elastic limit of the material is not exceeded, the stress in that material is directly proportional to what? The strain. Now, this chart we have here, we are seeing a stress plotted against a strain. So we're having stress versus strain. And in this material, we coin the relationship and the features of this Hookean material. So this is a diagram showing the behavior of a mill steel when subjected to tensile stress. So we're having this point. This point here is called the elastic limit. So we have point P from this origin of those two of this graph. So we have where P is what the elastic limit of this material. So this is the elastic limit of the material. So Hooke's law obeys, Hooke's law works in this curve. Hooke's law will be applied in this curve where the elastic limit of the material is not exceeded. Is that understood? So now we see where Z is a point called the yield stress. U is a point called the ultimate stress. The ultimate stress is the highest stress material can carry before it breaks or before it fails. So you can see this dot 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 signifying this is the point of the breakage of that material. DOP, which is DOP, is called the elastic region of this material. So what Hooke's law is saying that provided the elastic limit of that material is not exceeded, the stress is directly proportional to what? The strain. Now, of course, in mathematics, where you have a case where you're having a proportionality sign, for you to remove this proportionality, you introduce a constant. So we are introducing a constant, and we are having that the stress is directly proportional to what? E strain. Where E is called the modulus of elasticity. Now, let's make that modulus of elasticity the subject formula. So we have the stress all over what? The strain. Take note, what is the unit of this constant? Take note, this constant is called the Young modulus constant. Now take note, since we know that the strain earlier is dimensionless, the constant of or the modulus of elasticity will be the same unit with stress. So therefore, the unit is Newton per meter squared. Very, very important. The unit for the strain of the for the modulus of elasticity is the same as the unit for stress. It is very, very, very important to take note of that. Now, let me show you something. Let me coin some relationship from this. Now, in our earlier discussion, we said that the stress signifies the force per unit area. We also say that the strain is what? Extension over length. And when we substitute these parameters into this for value of our modulus of elasticity, we have that E is equals to, which we represent everything here as P over A. So we're having P over A brackets now divided by, we're having our strain here, which we represent as what? Deformation over the length. So we're having this over deformation over the length. We're having our E is equals to now in operations like this, arithmetic operations, for you to change this to multiplication, you take the inverse of this value you have here. So we're having P over A multiplied. When it change from division to multiplication, it will, here is going to inverse. So you're going to have L over what? Deformation. When you multiply P by L, you're going to have PL. When you multiply A by this, you're going to have A deformation. So take note that the formula for modulus of elasticity, which is a constant when you, the stress is directly proportional to the strain, which is the Hooke's law, in relation to materials in engineering, which is strength of materials, we are having that it's going to PL over the area multiplied by the deformation. Take note of this formula. Now, in relation where they say you should calculate the deformation, we're going to make deformation subject formula, which will say that deformation is equals to what? PL over A multiplied by E. So take note, this is the formula for what? Deformation or elongation or extension of any material when subjected to stress and strain. So now we'll go on to strain energy.